Hi everyone, so today's lesson is on polynomials and how we classify them by their degree, how we write them in standard form, and how we add and subtract polynomials. So first of all, the definition of a polynomial is an expression consisting of many terms. So we will not have an equal sign here. We will see only an expression with plus and minus signs in between each one of these terms. Now in standard form, we want to write our final answers in this format, and what that means is it must be in alphabetical order and then the highest exponent or the exponents written greatest to least. So we want to start with that highest exponent and then put them in order all the way down to our smallest exponent. If we're looking at this expression, we have an example here where you can see you have x to the third, x to the second, x to the first, even though there's not an exponent written there, we assume it's a 1, and then our constant term, which really has an exponent of 0. The highest exponent in any of these expressions is known as the degree. So when we classify these polynomials, they are classified by their degree and their number of terms. So degree is the same as the exponent or the power of the highest exponent, and the number of terms is the amount of basically pieces of this expression. So if you look at your example here, you have 4 pieces to this expression, which means there are 4 terms in that expression here. So if you look at your first one, using your chart, it says classify the following polynomials by degree and number of terms. So in the first problem, we see the number 6. The number 6 has no variable, which means it has an exponent of 0 or a degree of 0. So we look at our chart, we see where the degree is 0. That's the first word. We'll put the word constant in front, and then we see there's only one term, so 1 is known as a monomial, with mono meaning 1. So constant monomial would be your answer for number 1. For number 2, you have negative 2x. Keep in mind there's an exponent of 1 after this x. So 1 is your degree, so we find a degree of 1, which is linear. And there is still only one term, so one term known as monomial. For the third one, we see the same idea. We have 7x, that is x to the first, so our highest exponent is still a 1. That would still mean that this is a linear expression. However, we now have 2 terms, and for an expression with 2 terms, we will use the word binomial. And I think most of us would understand bi as in bicycle has 2 wheels, a binomial has 2 terms. So this would be known as a linear binomial. All right, now for question number 4, we see a degree of 2. That's our highest exponent, so we classify it based off that highest degree. That is known as quadratic. And then we should notice that there are 3 terms here. With 3 terms, we have the word trinomial, and obviously trinomial meaning 3. Now for the last two problems here for number 5, you can see your highest exponent is a 3. That is classified as cubic, and there are 2 terms which would classify this as a binomial. So cubic binomial would be the proper classification for number 5. Last but not least, we have number 6. Highest exponent is a 4. 4 is known as quartic. So quartic would be the first classification, and then there are 4 terms. Anything with 4 or more terms we consider a polynomial. Polynomial is kind of the overarching name for all of these, but if it has 1, 2, or 3 terms, we have a more specific name. For 4 or more, we only use the word polynomial to classify an expression of that length. Okay, so that's the classifying process for polynomials. Now, to write the polynomials in standard form, I mentioned that there's 2 rules here. We must put them in order from from greatest to least in terms of the exponents. So if you look at the exponents here, you have 2x squared, you have 3x, and your constant term will always come last because that has an exponent of 0. So when we write this, we want to include the sign that's in front of it. So if it's positive, it will stay positive. 2x squared, the 3x was positive, so we'll put plus 3x, and the 1 is also positive, so we'll put a plus 1 after that. In number 8, you'll notice you have an x to the third. That should go first. Then we look for the x squared term, which is also positive. We look for the x term next, which is negative, so can keep that sign. And then again, ending with our constant, which is a positive 64. Number 9, same idea. We have an x to the third. We have an x squared. We have an x, and we have a constant term of 28. Number 10, we're sticking with the x variable here. Now I have an x to the third, so that negative x to the third will go first. The x is next because we do not have an x squared in this situation, and always ending with that constant, it's a positive 24. Now 11 and 12, you'll notice that you actually have 2 variables. So when we have 2 variables, we have to put them in alphabetical order, still in order of descending exponents. So we have a's and b's. So we want every term that starts with an a first. That would be a to the third. Then we have an a squared. So this 5a squared b squared would come next. Then we have a 2ab. We still have an a, so that would still come after this. And then anything that just has a b will start at the end of the expression. All right, now for the last one, similar idea here. We have this x to the third. X will come before y, so anything with an x, negative x to the third, will be first. We have another x term, negative 7x squared y squared. Then we want to continue with letters, so I now see this 5y to the third. And then last but not least, our constant term with no letters will be tacked on the end of that expression. So writing our final answers in standard form is super important, especially for multiple choice type questions where you're trying to match your answer to a multiple choice answer. They will typically be written in this standard form. So if we can get in that habit, it's a great thing to get into. So that's kind of the introduction for our polynomials here. On the back side of this paper, we talk about adding and subtracting polynomials. So there's two examples here at the top. When we're adding polynomials together, we're thinking addition. Really the main concept here, something we've talked about before, is to combine our like terms. All right, for addition, that means I'm going to take and add together a negative 2x squared with a positive 3x squared. Now, when you are adding or subtracting, the exponents do not change. The only thing that we're really doing here is adding negative 2 and positive 3, which would give us a 1x squared. Then we're adding our x's together, so 18x and a negative 8x. 18 plus negative 8 would be 10x. And then we're adding our constants together. In this case, that's 15 and negative 10, which would give us a positive 5. Notice how when I talked through that, I picked out the exponents in order of their exponents here, so we could write our answer in standard form. Now for subtraction, things change a little bit. For subtraction, we have to keep in mind that this is basically a negative 1 that we will have to distribute to every term in our expression when we are subtracting. So before we can combine our like terms, we're going to bring down our first expression, and then we're going to distribute this subtraction sign into our second parenthesis. So negative 10x, negative 3x squared, and negative 2. Notice that subtraction just changes the sign of each one of these terms. Once you have done that, it is back to this skill of combining like terms. So we're going to look for that highest exponent. So I have a 6x squared minus a 3x squared, which will give us 3x squared. I have a 7x and a negative 10x, which would give us a negative 3x. And then I have a negative 2, but there's no other constant to combine that with, so we will just bring that down into our final answer. So example 2, we would get 3x squared minus 3x minus 2. Now, to finish off this worksheet, I would like you guys to work at the bottom of the page. It says solve the following problems, match that answer to the correct letter of the alphabet, and enter that letter on the blank corresponding to the problem. So if I look at question number 1, I see my x squareds, 2x squared and 3x squared. I'll get 5x squared. I see 4x and 6x, which would give me 10x. And I see 1 plus 5, which will give me a positive 6. This solution that you get should match one of the answers here in the row. And you can see right here it matches letter U. So for number 1, anywhere you see a number 1 at the top of the page, you are going to write the letter U on the line. And I would encourage you to cross these off. You will not use every one of these answers. However, most of them do get used, and if your answer is not in one of the answers that is given here, you did something incorrectly. So please keep that in mind when you're working through that. Remember, for the subtraction problems, you do have to distribute that negative 1. So on something like number 9, you'll have x squared plus 6 minus 6 plus x squared. So in this situation, we combine these x squareds. Remember, there's 1's in front of them. That would be 2x squared. And 6 minus 6, they will cancel out, leaving you with a 0. So this would be your answer there for number 9. Good luck with the rest of the page, and let me know if you guys have any questions. We'll talk more about this next week.